Today I have a lesson on surface area of 3D shapes. So the surface area is the total area of the outside of an object. The surface area of a 3D shape is equal to the sum, so sum means addition, of the areas of all of the faces. Okay, so let's talk about an example. So pretend you had to wrap a present and say that it was a box. Think of how much wrapping paper you would need to wrap that box. So in order to do so, you need to find the surface area. So you would need to find the area of all of those faces. So in a box, it would most likely be rectangles. So find the area of each rectangle and then add them all together to find the surface area. We are going to talk about specific formulas for each of the 3D shapes to find the surface area. So what is a 3D figure? A 3D figure is a solid shape with a length, a width, and a height. So a rectangular prism, if you notice in the title, rectangular, we're talking about a rectangle. So a rectangular prism is made up of rectangles. A cube is made up of all the faces are squares. You could think of like a dice. A cylinder is made up of two circles, one on the top and one on the bottom, and there's this rectangular shape in the middle that wraps around. Then there is, so that is a cylinder. Then we have a pyramid. So you might have learned about pyramids when you studied ancient Egypt in history class. So a pyramid is made up of a rectangular shape on the bottom and triangles on the outside. And then there is a cone. So a cone, the shape highlighting in pink. So this shape is made up of, this figure I should say, this 3D figure has a circle as the base and then this triangular shape up top. So as so. So these are all 3D figures and they each have a length, a width, and a height. So most 3D figures have faces. So the faces are the flat surfaces or sides. So in this cube here, our face is this whole thing, this whole square right here. Okay, so a face, the flat surface or sides on this cube, there's one in the front and one in the back, one on the right side, one on the left side, so that's 4, and then one on the top and one on the bottom, so that's 6 total. So faces are the flat surfaces or sides. Then the edges are where the faces meet each other. So this is an edge in red here, then we have another edge here, right? I could keep going. This is an edge. We have an edge down here. These are all edges. Okay? And then vertices, or we can call them vertex as well, one point. So vertices are points where the edges meet, or you can also think of it as the corners. So we have a corner here, a vertex here. We have another one here, right? There's also one over here. There's one here. So all of the corners make up the vertices. So let's look at an example. So this figure on the right is a cube. So you can think of a cube if you ever played with a dice before, that's a cube shape. So let's identify how many faces are on this cube. So again, faces are the flat surfaces or sides. So if we look here, so we have one on the front, one on the back, one on the left side, one on the right side, one on the top, one on the bottom. So that's a total of 1, 2, 3, 4, 5, 6. And again, just like a dice, that has 6 faces. Edges, we go back, edges are where the faces meet each other. So let's see how many faces this cube has. So we have edges this cube has. So we have edge here, so that's 1, 2, 3, 4. There's one in the back here, 5, 6, 7, one here, 8, 9, one in the back, 10, 11, and 12. So those are all the edges. Again, if you were to like trace this cube, and there are a total of 12. And the vertices are the corners. So let's see how many corners this figure has. So there's one here, 1, and I'm making them in green, 2, 3, 4, 5, 6, 7, 8. So there are a total of 8 vertices. Okay. So the next thing I want to talk about here is nets. So a net is the pattern made when a 3D figure is laid out flat, showing each face of the figure. So if you notice on the left side here, we have a cube. Okay, this is the 3D figure cube. If we were to take this cube apart, it would create this net. Okay, if we were to lay it out flat. Now, maybe in middle school, you worked with nets where you were given the net. So you were given this flat, you were given a flat piece of paper here with all of these squares, and you were asked to fold it to make a 3D figure. Maybe you use tape and glue. And when you fold all of these faces in, it will make the cube. So that is a net. Let's talk about specific formulas for surface area. So the first figure we're going to talk about is a cube. So the surface area formula for a cube we're going to use is surface area equals 6 times s squared. So 6 is just the number of faces on the cube. There's 6 of them. So that's never going to change. You're always going to have that 6 there because it's part of the formula. Times s. S stands for side. Right, so whatever number is given to you for the side, and then you're going to square that number. Let's look at an example. So the surface area formula we're using for a cube is surface area equals 6 times s squared. So in our problem here, s is 5, right? This is our side, so we have s equals 5. Okay, so in the formula where there's an s, we're going to plug in a 5. So we have surface area equals 6 times, instead of s, we're plugging in 5, and that's going to be squared. Now we have to follow PEMDAS order of operations, PEMDAS. So we're going to do we're going to do the exponent. So let me highlight that. We're going to do the exponent first. So we're going to keep the 6. 6 times 5 squared is 25. Now we can multiply. 6 times 25 is 150 inches squared. So the surface area of this cube is 150 inches squared. The next 3D figure I would like to discuss is a rectangular prism. So rectangular, right in the title of this figure, rectangular, think of a rectangle. In the previous unit, we worked with just area. So the area of a rectangle is base times height, or that's the same as length times width. So you could, if you wanted to, you could go through and find the area of each of the rectangles. Like if you were to take this 3D figure apart and make its net, and you found the area of each face, which is a rectangle, and then add those all together, you could get the surface area that way. Or you could use the surface area of a rectangular prism formula, which is here in yellow. So it's this right there. So if you look down below, I labeled each part of the rectangular prism by color. So length, we're going to use the letter L to represent length. And length is on the bottom here. It goes right to left, left to right, horizontal. Then we have the width. So the width is how wide it is from front to back, and we're going to use W. And then height is how tall it is, the vertical line up and down, and we're going to use the letter H. So the formula for the surface area of a rectangular prism is 2 times length times width plus 2 times height times width plus 2 times length times height. Here's an example. Let's find the surface area of the rectangular prism. So we're going to use the formula 2 times length times width plus 2 times height times width plus 2 times length times height. Let's start off by labeling our rectangular prism. So our length, our L, is 5. Our width, right, from front to back, how wide it is 4. And our height, how tall it is 7. Now we just need to plug those numbers into our formula. So the formula I have up top here. So this is the formula, and we're just going to plug in the numbers for the letters. And again, we're getting the numbers from our figure on the left. So we have 2, that's part of the formula, so you're going to keep that, you're not changing that. So 2 times L is 5, times width is 4, so 2 times 5 times 4, plus 2 times H is 7, 7 times W is 4, and then plus 2 times L is 5, times height is 7. All right, now we want to follow order of operations. So PEMDAS P stands for parentheses. So we need to do parentheses first. So we are going to, let me highlight each. So we need to solve inside the parentheses first. So we'll do 5 times 4, then 7 times 4, and then 5 times 7. So we're going to keep the 2 on the outside of those parentheses. So we have 2 times 5 times 4 is 20, plus 2, 7 times 4 is 28, plus 2, 5 times 7 is 35. So we have 2 times 20, plus 2 times 28, plus 2 times 35. Now we PEMDAS, so P, we did parentheses. E, there are no exponents. M is multiplication, so we need to multiply. So we have to do multiplication before addition. So we're going to do 2 times 20, then 2 times 28, and then 2 times 35. 2 times 20 is 40, plus 2 times 28 is 56, plus 2 times 35 is 70. Oh, and I had the answer revealed, but when we add those all together, 40 plus 56 plus 70, the surface area of this rectangular prism is 166 centimeters squared. Now I do want to point out that once you are able to go from, once you have the formula and you're able to identify each part and you're able to go from the formula to this here, once you input everything into its spot, you could just plug this whole thing right here into a calculator if you have a calculator. You just have to remember to include the parentheses where you see them. So in a calculator, you'd have to do 2 parenthesis 5 times 4 close parenthesis plus 2 parenthesis 7 times 4 close parenthesis plus 2 parenthesis 5 times 7 close parenthesis. And if you use a calculator, it will skip these 2 steps and just give you the answer. Okay, as long as you set up the numbers in the correct places. All right, the next surface area we are going to talk about is the surface area for a cylinder. So the formula for surface area of a cylinder is 2 times pi times r squared plus 2 times pi times r times h. Now here I broke down what that means. So that means you're doing 2 times pi times the radius, because r stands for radius, and that's going to be squared, plus this right here, 2 times pi times r. This is the formula for circumference, which we talked about last week. So plus circumference times height, okay? So if you're looking at the cylinder on the left, we get our radius, the r. Remember, the bottom of this cylinder is a circle. So we have a circle on the bottom. And the radius is the segment that goes from the center of the circle to the edge. And this we represent with the letter R. And then the height is how tall it is. So the vertical line here, and we're going to use the letter H to represent height. Okay, so let's look at an example of this. So here we have an example of a cylinder. So we have the surface area formula. Again, we're going to use this formula to find the surface area of the cylinder. So let's identify our parts on the cylinder. So we have from the center of the circle to the edge is our radius. So our radius is 7. And then our height, I'm going to make it blue so it matches the colors. So again, our radius from the center to the edge is our radius. And then how tall it is from the vertical line, top to bottom here, we have our height, which is 11. Okay, so now we're going to just take our formula, and wherever there is an R, we're going to plug in a 7, and wherever there is an H, we're going to plug in an 11. All the other parts in black, so the 2 times pi, that's all going to stay the same. That's part of the formula. So we have 2 times pi times R is 7, so 7 squared, plus 2 times pi times R is 7 times height is 11, okay? So now what I did is I broke these up into 2 different groups. So we're going to do this part first. We're going to do that part together, and then do this part together. And then once you find the 2 parts, you can add them together. So we have 2 times pi times 7 squared is going to be 307.72. Again, you can just plug that right into your calculator. And then the other side is 2 times pi times 7 times 11, and you'll get 483.56. And then the last step here is to just add 307.72 plus 483.56 and get 791.28 meters squared. And again, remember, we have to square the units because we're talking about area here. So that is how you find the surface area of a cylinder. Now let's look at an example of a cone. So for a cone, we have these components here. So we have the height. So the height, again, how tall it is. So it's right in the middle here. The vertical line. And we use the letter H to represent height. Then we have the radius. Again, that is part of the circle. So it's from the center to the edge, and that's the radius. We use the letter R. And then this is a new term here, slant height. So, you know, a slant means kind of like a tilt. Something's on a slant, it's not straight. So the slant height is basically just the side here of this triangular shape. And we use the letter L to represent slant height. So you might see it with the letter L, or you might see the letter L like this, like a cursive L. So it would be an L like this or a cursive L. And that means slant height. Okay. So we're going to use the formula pi times r squared plus pi times r times slant height, which is L, to find the surface area of a cone. So let's look at an example. So again, we're using the formula pi times r, which is radius, squared, plus pi times r times L, and L is slant height. So let's look at our example. Let's identify our parts. So let's identify our radius, the r. So again, the radius is with the circle at the bottom. The bottom is a circle, the base is a circle. So we're going from the center to the edge, and this is our radius. So 4 is our radius. And our slant height, remember a slant height is, you can think of it like the side of a triangle here, or the side of this figure. It's the tilted side. It's not straight. So this is our slant height. So this is our L. So our L is 5. Now we're going to take those numbers and plug them into the formula. Remember, in the formula, the information in black is going to stay the same. So we have pi times r is 4, so pi times 4 squared, plus pi times r again is 4, times L, which is 5. Okay. Now I grouped these together, so we're going to do pi times 4 squared together, and then pi times 4 times 5 together. Again, as a reminder, you could, if you wanted to, you could just take this whole thing here, this whole equation, and plug it right into your calculator. But you need to remember to include the parentheses if you do it that way. But I'm going to show you how to break it down because you do need to know how to do it that way as well. So pi times 4 squared. So 4 squared is 16. So we have pi times 16 plus pi times 4 times 5. So again, I'm following PEMDAS, so I did that exponent first. Okay, so we're still going to do these together. So we're going to do pi times 16, and then we're going to do pi times 4 times 5, and then we'll add them together. So we have pi times 16 is 50.24, and then we have pi times 4 times 5 is 62.8. And then our last step is just to add those two numbers together, 50.24 plus 62.8, and that is 113.04 centimeters squared. So that is how you find the surface area of a cone. The next one I want to talk about is a square pyramid. So this shape, this figure here is a square pyramid because if you notice on the bottom, a pyramid has a square base. So this is a square. Okay. You know that, so this is a square, and we know a square is made up of sides. So we're going to use the letter S to represent side. Then we have the height. So the height, again, is how tall it is. So the height here, vertical line, we use the letter H. And then we have slant height again. So slant height is just the tilted line on the side of this pyramid here. The slant height, or you could think of it like the side of the pyramid. And we're going to use, so here they use the cursive L, or you can just use the letter L. Okay. So we have slant height. So again, you're going to use the letter L or the cursive L. Height, we use the H, and side, we use S. So the surface area formula is surface area equals side squared plus 2 times side times S times L. So that is S squared, so side squared plus 2 times side times slant height. down here, I break that down a little more. That is basically the same exact thing as the area of the base, right? We know the base is a square. In order to find the area of a square, you do side times side. So you do side times side to find the area of a square, which is the same thing as side squared. And then the area of 4 triangles, so you'd have to find the area of the 4 triangles, and you could add those together. So you could do it that way as well, but for now we're going to focus on the formula. So let's look at an example. So we're using the formula. Surface area equals S squared plus 2 times S times L. Okay, so let's identify our parts. So let's identify S first, so the side. So the side of the base is 16. So 16 is S. And then if you notice, it gives us the 15 in the middle here. This is a straight vertical line. So that is the H. This is H, not the slant height. Because remember, slant height is like tilted. So we don't need to know the 15H for this formula, but I'm just pointing that out. So then our slant height is right here, because if you notice, it's a slanted line. And that's our L. So 17 is L. So let's plug in our information. So we have surface area is S squared, so S is 16. 16 squared plus 2 times S again is 16 times L is 17. Now we're going to solve this. So we have 16 squared is 256 plus 2 times, so this here, 2 times 16 times 17 is 544. And then we can add those together. 256 plus 544 is 800. Sorry, I forgot to include inches squared. So the surface area of this pyramid is 800 inches squared. And then the last figure I wanted to discuss is a triangular prism. So this here we have a triangular prism. It's made up of triangles and rectangles. So you could think of this two ways to find the surface area. So you could take the sum of all the areas of the faces. So a triangular prism is made up of 2 triangles. So it's made up of 2 triangles, and we know the area of a triangle is base times height divided by 2. So we have, in the front here, we have 1 triangle, and in the back we have another triangle. So you could find the area of the triangles, which is base times height divided by 2 for each of those triangles. And then it's also made up of 3 rectangles, okay? There's a rectangle down the bottom. There's a rectangle on the side. And then there's a rectangle on the other side. I know it's kind of hard to see, but there are 3 rectangles, and we know the area of a rectangle is base times height. So you could find the area of the 2 triangles and the areas of the 3 rectangles and then add all those together. Or we could just follow the surface area formula, which is surface area equals base times height plus L times S plus L times B plus L times C. Whew. So I know that's a lot, but all of the information is labeled here on the picture. And you just got to plug in the information into the formula. So we have B. B is our base, right here. So this is B, so I'm in red. Then we have height. So the height of the triangle, so that will be given to you. Remember, it's that vertical line, how high it is. We use H. Then we have L, so L is the slant height. So L is right here. The slant height in this example, for a triangular prism, it's right here. So that's L. Then we have S, so that's side. That's back here, I'm gonna in blue, so that's S. Okay. We have L again, B again is the base, L again is the slant height, and then C. Color haven't I used? I think I used them all. To repeat. So C is right here. Okay. So you can use this visual to help you when you're solving, just so you know which number goes with which part of the triangular prism. But let's look at an example. So we have the surface area formula. So we have B times H times L times S plus L times B times L times C. Okay, so let's start by labeling our parts. So we could refer back, let's refer back here. So let's identify B first. So B is the base here on the bottom. See it in red? So our base right here, the bottom here is 12. So 12 is B. Our height is how tall it is, that vertical line. So our height here is 8. Okay. Then we can do our slant height. So if you see that L, it's in purple on the right. So we have 14 for our slant height. Okay. And then we have C. So if we look back here, C, this is C. We have C here. And did I get it all? Oh, an S. S, if it's back here in blue, this is S. Okay. And S on our example is right here. So this is S. So I just label each part by referencing that visual on the last page is very helpful. So let's fill in our numbers into the formula. So we have B, so we have 12 times H is 8, plus L, the slant height is 14, times S is 10, plus L, again the slant height, which is 14, times B is 12, plus L, the slant height, which is 14, times C, which is 10. Okay. Again, I know that's a lot of numbers to put in, but once you plug them all in, then you can just solve. So again, you could plug this whole thing right in your calculator, but let's break it down. So you have to follow PEMDAS. So I see the operations of multiplication and addition. So PEMDAS, P-E-M, M comes before D-A-S, comes before multiplication. So we're going to do all the multiplication first. So you're going to do 12 times 8, 14 times 10, 14 times 12, and what color didn't I use? 14 times 10. Okay, so we have 12 times 8 is 96, plus 14 times 10 is 140, plus 14 times 12 is 168, plus 14 times 10 is 140. Now add those together, 96 plus 140 plus 168 plus 140 is 544 inches squared. So the surface area of this triangular prism is 544 inches squared. So that's one way you could do it, by using that formula, or you can break it up. So I mentioned that this figure is made up of two triangles. So two triangles, and it's made up of three rectangles. So we know that the area of a triangle is base times height. So if we're just focusing on, I'm going to erase this. If we're just focusing on the triangle, I see a base of 12 and a height of 8. Okay, So we can plug those in. So we have base times height, 12 times 8 divided by 2. So we have 12 times 8 is 96 divided by 2. So that means the area of the triangle is 48. So the area of this triangle here is 48. Now we need to be careful because there are two triangles. There's one in the front here, so this is one of the triangles in blue. And then there's one in the back. You can't see it, but there's one in the back here. So there are two triangles. So since the area of this, we know the area of one of the triangles is 48. So since there are two triangles, we need to multiply 48 times 2, which is 96. So we have 96. We need that number. So we have 96. Now we know that there are 3 rectangles. So there's one rectangle on the side here. Trying to make it in yellow. And this rectangle is 10 by 14. So 10 times 14 is this rectangle. Then we have another rectangle on the left side. So I know it's hard to see, but it looks like it is 10, right? 10 is this edge in the top here is 14, because since this is 14, the opposite side is 14. So we have another rectangle that is 10 by 14. Okay, and then the other rectangle is on the bottom, and that rectangle is going to be, so it's on the bottom, so it's the base. So we know we have 12, because I got the 12 from right here. And then we know the side here is 14. So we have another one that is 12 by 14. So to find the areas of the rectangles, we need to do 10 times 14, which is 140, 12 times 14, which is 168, and 10 times 14, which is 140. Then we need to we need to add those together. So we have 96. We're adding all of the faces together. The area of each face, 96 plus 140 plus 168, which I did here, wrote here as well. And you find that the surface area is 544 inches squared, which we got in both places. Both ways we got it. We got 544 inches squared when we used the formula, and we got it again down here when we broke it down. So that is how you find the surface area of rectangular prisms, cubes, cylinders, pyramids, and cones.